In this video, I'm going to discuss section 10.3, for which we test the claims about the mean now, not the proportion anymore, the mean. Let's read the question. A particular brand of tire claims that its deluxe tire averages more than 40,000 miles before it needs to be replaced. So guys, more means greater than. That should be in the alternative. And you put the 40,000 miles right here. This is the claim. And then equal to 40,000 will be in the null hypothesis. So let's see what he gives us here. He gives us 28 tire survey, so N is 28. The mean lifespan was 42,500, so X bar, that's the sample mean. With a standard deviation of 3,800, that's the sample standard deviation S, which is 3,800 miles. And he gives you alpha to be 0.05. Now, if he gives you the sample standard deviation, you have to use a t-distribution. So then you have to use a t-test that is built on your calculator or on Statcrunch. So because here he gave us a sample, he provided us with the sample mean and the sample standard deviation, then you must use what we call the t-test. And I'm going to show you how to do this on the calculator. So I'm going to get the calculator up and running. And let me just do that. So you're going to go to stat, tests, it's number 2. Okay, I have summary, I don't have the actual data. Okay, mu0. What was mu0? 40,000. What the value in the null hypothesis? 40,000. X bar, let me look them up one more time. 42,500 and 3,800. 3,800. Is that what we have for the standard deviation? Yeah. N, how many tires did we have in the sample? I think it was 28. And what is the sign in the alternative? It's greater than. Enter. And then before I hit, I want to change the colors here. Okay, blue. Now we should be able to see the draw. All right. So the test statistic, let me just make sure that I did not put anything. T-stat. Yeah, I made a mistake. It should be 40,000 here. I got some strange results, a very large test statistic. Now it's gonna work. So probably some of you noticed that, but I just noticed it. All right. So P equals E 9 times E minus 4. E minus 4 means you have to move the decimal point 4 digits to the left, so it's going to be 0.0009, which is very small. And T is 3.481. So let's write that down. What was it again? 3.481. And the p-value, guys, so 0.0009. Let's explain it again. 9e minus 4. You don't put this as an answer. There is a decimal point right here. It means you have to move the decimal point 4 digits to the left. So what is the p-value here if I want to show you a visual, guys? So if you put t0, which is the 3.48 on the right here, the p-value will be the area on the right. And since the 3.48 will turn out to be very, very close to the tail right here, so you won't see any much of the p-value. That's why it's very small. So p-value is this. Is this less than alpha? Of course it is less than alpha. Alpha is 5%. So what's the decision, guys? Reject HO. And what's the conclusion? There is enough evidence. At what level of significance? At the 5% level of significance. Now, when you're doing your homework online, you have a choice between to use the word support or reject. Remember, if the claim is in H1, you will never use the word reject. Since you rejected HO, that means H1 is good. So you say there is enough evidence at the 5% level of significance to support the claim. I'm not going to write the whole thing, but you should write it, just on your exam paper, that the deluxe tire averaged more than 40,000 miles before it needs to be replaced. Now, how can we do this using Statcrunch? Let me get Statcrunch, guys, and show you how to do that. All right, so I'm going to close this, go to Stat. Now it's when you test the mean, you have two choices, either Z-stats or T-stats. Let me tell you when to use each. You use T-stats if he provide you with the sample standard deviation. You will use Z-stat if he gives you the population standard deviation. So in our case, it's going to be T-stat, one sample with summary. Okay, sample mean was what? 42,500. Sample standard deviation was 3,800. Sample size, we have 28 tires. And what was the value we're testing against? It's 40,000. And what's the alternative sign? You always have to choose the alternative sign. I'm going to give you a p-value plot. You're not going to see much in there. And let's do it. I'll show you what we got. And look, guys, exactly what I got on the calculator, 3.481. Look at the p-value, same thing. The nice thing about Statcrunch, it will give you the p-value to 4 decimal places. And look, the p-value, the sketch of the p-value. Oops, sorry. All right, here. Yeah, you don't see, it's very small. That's why there is not much shading here. You don't see anything. So this is how you perform a hypothesis test for the mean. Now I'm going to show you another example where we use data instead of summary. So I'm just going to scroll down to the next exercise right here. It says the mean number of sick days an employee takes per year is believed to be about 10. Members of a personnel department do not believe this figure, so they don't think it's 10. They randomly survey 12 employees the number of sick days they took for the past year as follows. Should the personnel team believe that the mean number is not 10? So they're asking us, is the mean not 10? So how do you state the null in the alternative hypothesis, guys? So this is the mean. This is the mean. Not 10 right here. Claim. And then equals to 10 will be right here. And now we need T0. We need the p-value. We need to make a decision whether we should reject or fail to reject the null hypothesis and write the conclusion. In order for me to do this, I have to enter and put this data in a list on the calculator or in Statcrunch. So I'm going to do it first on the calculator, guys. Okay, guys, so what I did stat, edit, right here, enter, and I selected edit, and that's enter right here. And then I enter the data in there. And now I'm going to go to stat, tests, and it's a t-test unless if he gives you explicitly the population standard deviation, tell you that assume that the population standard deviation is known to be, etc., you will always use the t-test. Otherwise, if he gives you population standard deviation, you use z-test. So t-test, enter. Okay, now we have data, guys. Enter. Okay, what's the value in the null hypothesis? It's 10. Where did I put my list in L1? You don't change the frequency, leave it always at 1. What's the sign in the alternative hypothesis? Not equal. If it is blinking like that, it's not selected yet. You have to press enter to select it. And now I want to do, if you like, draw. I'll show you the p-value in action here. You see the p-value on both sides because they call it two-tailed test. It's not equal means two-tailed test. So t is negative 1.729 and the p-value is 0.1118. So let's write them down. And p-value 0.1118. Let's compare it with alpha. This is bigger than alpha. So what's the decision, guys? Fail to reject HO. If you fail to reject the null hypothesis and your claim is in the alternative, this should be H1, you will not support the claim because you failed to reject HO. So you say there is not enough evidence. At what level? At the 5% level of significance to support the claim that the mean number is not 10. That the mean number is not 10. How do you do this with Statcrunch? Let's show you how to do that with Statcrunch. So what I did, guys, I put in the data into variable 1 in Statcrunch. And now I'm going to go to stat, tstat, one sample, but this time with data. Select the column where your data is in. We're testing the hypothesis against what number? You need to change the 0 here against 10 this time. And our alternative is not equal to 10. And if you guys want to see the p-value plot, you just select it from here. And you want to see what I'm doing next. I'm going to hit compute. You don't see the compute, but it is there. Let me just reduce this and I can show it to you. You see right here. And you want to see everything right here. Look, same thing that we got on the calculator. Negative 1.729 and p-value is 0.1118, which is bigger than alpha, so you fail to reject the null hypothesis. You want to see the p-value? It's right there. This is half of the p-value here and half of the p-value there. And this number right here, guys, is negative 1.729, and this one will be plus 1.729 because this is called two-tailed test. So we'll go there. So when you have a not equal, this is called the two-tailed test. When you have a less than, this is called the left-tailed test. And when you have a greater than, this is called a right-tailed test. Now I'm going to show you an example, guys. I'm not going to do it, but I'm going to show you an example where you use z-test, not the t-test. Most of the time it's going to be the t-test, but let me show you an example where it turns out to be a z-test. All right. Previously, an organization reported that teenagers spent 4.5 hours per week on average on the phone. The organization thinks that currently the mean is higher. So if you want to write the null and the alternative hypothesis, guys, it will be HO, H1. Higher means bigger than 4.5, and this is the claim. And this will be equal to 4.5. The organization thinks that currently the mean is higher. 15 randomly chosen teenagers, so N is 15. We're asked how many hours per week they spend on the phone. The sample mean was 4.75, so that's X bar. And now pay attention, guys. Assume that the population standard deviation is 2. When I say population standard deviation is not S, it's called sigma, which is 2. In this case, we cannot use the T distribution. We have to use the Z distribution, and which means a Z test, not a T test. Test the hypothesis at alpha equal 5%. You know what? Let me show it to you before I end this video. So I'm just gonna show it to you. So you go to stat, tests, Z test, enter. Oops, sorry. Okay, we have stats, not the summary. U0 is what? 4.5. And sigma, you see that he put sigma, not S this time, 2. X bar is 4.75. And how many subject did we have? 15. And we're testing the claim that the mean is greater now. So I'm going to choose greater than. Sorry. I'm going to go here and press enter. And now you guys, you can see this in action. I'm going to do calculate for you. So Z is 0.48, and look at the p-value, is 0.3141, which is bigger than alpha. That means you fail to reject the null hypothesis, and your conclusion will be there is not enough evidence to support the claim that the mean is higher, which is more than 4.5. Using Statcrunch, guys, let me close this one. You go to stat, and not t-stat, z-stat, one sample with summary. Sample mean is 4.75. Standard deviation, population standard deviation is 2. Sample size is 15. We're testing against 4.5, and we want to test if the mean is bigger. And just hit compute. And look, 4 point, same thing, p-value is 0.3141, bigger than alpha. We fail to reject the null hypothesis, and conclusion, there is not enough evidence to support the claim. I hope those videos were very helpful. This is exactly what I need you to know, guys, as far as type of questions you're going to be seeing on the next exam that will be held on campus. One thing I would like just to mention before I wrap this up, when you test the proportions, sometimes he will ask you to check if the conditions of the test are met. For example, let's say you have HO H1B equals 0.2 and P not equal to 0.2. And before you do the test, he wants you to check if the conditions of the test are met. And let's say the sample size is like 300. Here's how you check the condition of the test. It's n times p0, 1 minus p0 must be greater than 10. P0 is the value that you get from the null hypothesis. So that will be 300 times 0.2 times 1 minus 0.2. If this number, guys, turns out to be bigger than 10, you'll go ahead and just perform the test. If not, you cannot perform the test. And that concludes everything.